Hey, hi. In this video, I'm going to show you how to build and deploy Flask API on AWS ECS, or generally called as a Forget service, with using Terraform Cloud and GitHub Actions. As you see in this PPT depicts my solution here. So here I'm going to show you like how to convert a Flask API source code into a Docker image with using Dockerfile, and how to push that Docker image into AWS ECR service. Once the image is pushed in a AWS ECR service, how to use that image reference to spin up Amazon ECS service with using the Terraform. As you see in this diagram, the flow of the demo is something like this. Here we have a developer who will be working on either Flask application source code, or he would be working on the infrastructure as a code for AWS ECR or Amazon ECS, right, at GitHub, right? So that's the reason it generally shows developer will be doing push and pull operation on the GitHub. On the GitHub, we will be hosting two types of source code. One, infrastructure as a code, which is required to host our Flask application source code, right? And we also have a Terraform code which will spin up the required infrastructure to host our application, right? And also we have a workflow definition which actually does the CI/CD of the solution here, right? And that's the reason I have represented the Dockerfile, which will help us to convert the Flask application into the Docker image. So once the Docker image has been built by GitHub Actions here, we're going to push that Docker image to AWS ECR. And then once the image is being pushed to AWS ECR, we will have a next task which actually creates the Amazon ECS cluster, that is Elastic Container Service cluster. In that cluster, we're going to create the Elastic service, basically in the sense Elastic ECS service, that is Elastic Container service cluster service, basically. And then in that cluster service, we're going to create a task which actually runs our Python Flask API, right? And here, how does the Amazon ECS represents the image which we built just now is by referencing the ECR ID. This is the general the flow of my solution. So here what I do is I'm going to quickly show you like how does this application is being built, how does the so how does that particular image is also gets hosted on Amazon ECS, right? And we're going to see that the application working within no min of time, basically. Yeah. So here what I do is I'm going to quickly run this code with using my GitHub Actions. So if I can show you back, so here this is my this is my source code, basically. As you see here, this is the AWS ECS lab. It is the repository which contains both the application Dockerfile and also the ECS infrastructure as a code with using Terraform. We also have workflows as well. So now what I do is I'm going to first run the application, then I'm going to walk you through the source code, basically. So to do that, basically what I do is I'm going to uncomment this. So first one here, in this case, I'm directly jumping into the solution. In the sense, let's realize how does this solution works. As of now, in the source code or in this my repository, as I showed you, my repository name, that is AWS ECS lab, is already hosting the required source code, that is source code of Flask API application, and the GitHub action definitions, and Terraform code for infrastructure as a code of ECS service, right? So without making delay, what I do is I'm going to first make you realize that my application is up, works fine, basically. Yeah. So what I do is I'm going to make it like a backspace here, quite, right? So I'm going to save this change, right? Let me merge the commit. So once the application is realized and I'm going to show you that the application is up and running fine, then I'm going to walk you through the code. So code walkthrough would be at the end. So first let me realize you that the application is deployed and it is working, right? All right, so I will say that demo directly. So for now what I do is I'm going to commit this code and sync it into the upstream, that is my GitHub repository, right? So once it is synced, I'm going to run the GitHub action workflows. So here, this is my repository code, which is just now got synced. You see, it just now got synced, right? So these are all my source code, which I'm going to walk you through after the demo. So now in this workflow, I have a workflow called 0 to ECR ECS. If I go to the GitHub actions, right? So right now I need to invoke this GitHub action. So before I run this GitHub actions, I will take you to the my AWS account. This is my AWS account. It has a VPC and the subnets. and which is required. So indeed, I'm just giving you hints. I'm going to connect the dots later as well with using the source code. For now, let's enjoy the demo here. So for example, here right now I don't have any repositories, since in this solution I need to create the repository manually, because this is only first time job, only one time job in the life cycle of the application. For that case, what I do is I'm going to create a private repository called ECS demo and just click on, that's all. I'll just click on create repository. So this is the only manual task I'm going to do. Rest all tasks I'm not going to do. I'm just going to click on the deploy. We're going to realize that application is up and running fine. As of now, you see there are no clusters here. I'm going to refresh it now. Now magic happens. If I go to the ECR ECS deployment workflow, I'm going to run the workflow by targeting to the default branch. Right, the workflow gets run. It will take 2 or 3 minutes. While it executes, I'm going to explain what is actually happening behind the scenes. Currently, it is starting the job. So let's see, how does the application is getting wrapped into a Docker image, and the Docker image is stored in AWS ECR. Then we have a next task which will spin up the image on ECS service, and in that service we are creating the container service. Container service contains a task which actually runs our application, that is Python Flask application, right? And the reference has been here. Let's go back to the source code here. As you see here, so currently it has done the checkout, which is fine. Now it has done the ECR setup, which is authentication to the AWS account. That is logged into Amazon ECR. Yes, logging into Amazon ECR is indeed required. And it has built the image. If you see here, it has built the image of my application. So if I can duplicate this and show you the source code meanwhile, parallel to this one. So we had a Dockerfile here. We have a Python app.py, which is a Flask application. Now that Flask application is wrapped into a container image, and that image is stored in Amazon ECR, which is a secure repository to store your private images, private container images. So the image is been built and it is pushed to Amazon ECR. So if I go to this one, so if I refresh it, we have created the repository just now, right? So we should see an image is been published. Here you go. So the image is been published here, and this is the latest image. It just now created. That is, so this is right now time, right? This is 17 September 1637, and this is the same time it has got created. All right. So now our image is pushed. Now it has to go to the next task. That is the first task is done. Now it has to done and deploy it has to go do the next task, which is Amazon ECS, right? And let's see what is it doing. So currently it is initializing the Terraform. I have a Terraform cloud. So basically the backend of this Terraform is stored in Terraform cloud as well. So currently it is doing the plan. If you see here, it is executing the plan, and it has estimated that it has to create 4 resources, 0 to destroy. And that is what happening in the Terraform cloud, in the Terraform apply stage. So if you see here, the creation of the service has done in a blink of eyes. That's all. So basically, so it has taken, if I go back to the run one, it has completed the job in 2 minutes. Within 2 minutes, my application is deployed on Amazon, ECS service. Now let's go to the Elastic container service page, and if you refresh it here, we have a cluster up and running fine. That is generally generally it is also called as a Fargate, that is AWS Fargate service, or in general it is a Elastic container service, which means that it is a PaaS container service. Here the nodes of the cluster or Kubernetes cluster is managed by AWS. What you are doing is you are just hosting your service as a container service, right? So in my case, my cluster, the annotation cluster here is demo API cluster, and in that one I have a service called, this is the Cloud Quick Lab service which we created. In that one I have one task. If you see the task definition, I have one task. This is the task. If I click on this one, so this is the task which we created now, and it contains a container, and this is the image which we referenced right now. So if I copy this image, if I go to the container, this latest image, you see this is the URI. It is being tagged, in the sense it is being referenced here, which means that what, in the sense our application is wrapped into the container image. That image is deployed in a ECR. Now it is working fine. Yeah. So if I go to the service again, click on the service to explore more about the service. So these are all the health and metrics about the services, which you can see it here, right? And in that one we also have a task. This is the task which I showed you. The task is created out of the image which I just now shown you. So here is a task will have a containers, nothing but you can consider a task equal to so basically a container. Container will containing a pod. Pod is nothing but it's an application, basically application created out of a container image, right? Now if we go to the logs, we're going to see the logs here. Right now it is now empty. This is the deployment has happened, so you can explore these services on your own. Now let's go and realize. Now, so if you see the events, these events have happened just now. It says service has reached a steady state, which means that configuration is as expected. If you go to the configurations more, so these are all the configurations. You see the launch type is forget, and then we have a networking. In the networking, if you refresh it here, so we have these kind of configurations. Yeah, click on this one, tags, networkings, configurations. Now we're going to explore the service. In the sense, we're going to try the service from the so we're going to try this service from the basically from the browser. So to do that, you need to click on a task. Let me go back to avoid the confusion. So go to the cluster, go to the service, click on the service. There will be a task in each service. Click on that, click on this task, right? Then here in the configuration, you see that these are the configurations of the task, which means that these are the configurations of your pod, basically, right? So click on this one, which is nothing but our Flask application, which is deployed on the ECS service, right? So right now, when I access this public IP address, which is nothing but endpoint of my application, which is hosted in an Elastic Container Service. So if I go here, so currently it is pointing nothing, but if you go to the configurations, so this will be this. If you go to this so basically if you go to the the configurations of this one, generally this service is exposed on port number 5000, which is we need to do right now. If you directly hit it to this endpoint, this is public IP address, you don't see anything. To access your real-time application, which is defined as per your pod, we need to access to the endpoint, that is 5000, right? And / then in the Python application, I have the paths. Basically, let me go to the paths. No worries, I'm going to explain these code. What are these code after some time? So here we have a two paths, that is time and random. So let's access those the API paths, right, by typing the exact path. If you type this one, here you go, right? So it is giving the response. In the sense, within fraction of 2 minutes, within 5 minutes, I'm able to create the container image, host it into ECR, and then deploy that image into the container registry, and then I am able to access the service within 2 minutes, which is really great, right? And everything here is managed as infrastructure as a code, including source code wrapped into the container image, pushing into the ECR, then creating an ECS service and deploying into the ECS service as well, right? All right, so likewise my application here is working as expected, right? So that is really cool. Okay, so this is how I have set up. Now what I do is I understand that you have patiently watching this one. Now what I do is I'm going to walk you through the code finally to how did I set up this one. I believe that you like this these walkthrough. Now let's see a more deeper, like how did I set up the code to achieve these scenarios. Okay, so with that note, what I do is I'm going to get you back to the my Visual Studio Code. So this is my Visual Studio Code. Basically this code is this Visual Studio Code. In this code I have cloned my repository. So the repository, when I say repository, this is the repository, right? So anyways, so I'm gonna give the link of this repository. You can download this source code from here and try it from your side, right? For now I have cloned this repository by going to this one. You can clone it like this. Yeah, so once this repository is cloned, let me walk you through the the parts of this source code. So here there are three parts. One is application, that is purely application, in the sense which deals with your business logic. Yeah, so when I say application, we need to deal with app.py file. So let me tell you what is this app.py file. This app.py file is a Python Flask application. Here it is just acting as an API. In this sense, I have written a Flask application which is acting as an API. So how did I do? So here this system, my laptop is been already installed with the Python Flask. If you are not done, you can do so by running the command, that is pip install flask, which will install a Flask modules in your system. And then only this green box, green mark will come, that is from Flask Python module you need to import the Flask. And then you have a random, that is just I need a random, and then import time as well, right? So with using the Flask class, we are creating an app object. In the sense, we are creating an application object. in that one we are actually defining the routes. Whatever you see here, so we are route is nothing but the API path or API URLs. So here time URL, in the sense the after the base server URL, after the base endpoint of your application, if you put a forward slash and time, the application will be running this code. In the sense it will be running this business logic. That's what you can understand. So here in this one we are just giving a current time. In the sense we are just telling that hey, get me this current time. Yeah. So what I do is just to make sure that our application is managed as an infrastructure as a code. Not only that, it also manages the versioning control. What we do is I will just add one more command saying like tested. I'm just adding one more component called as a tested. Yes. Yeah. So that after walking through the code, I'm gonna run this application again to help you to understand that yes, this application is now managed as an infrastructure as a code. Plus, versioning is also managed very easily. For example, say you are introducing new feature in your application. Let's see if that works. Now we have introduced tested equal to s in the time as well. So I will say tested time. Let me give as a time equal to s. Yeah. So what does this means? In the sense, whenever you run this path, it will gonna return an object that is a JSON object, and it contains these many key value pairs. Right. All right. So likewise, we also have another path, another routing that is random. So it does return the response, right? Similarly, let's go to another path, that is if you are marking your base URL with the / random, it's gonna run this code piece. In the sense, this is a code piece, which means that here we are actually generating a random number with using this format. Yeah. And then we are actually returning that same random number in this dictionary. So this dictionary has keys and messages like this. All right. So I'm gonna just do undo this. I'm gonna, now what we are doing is I'm just modifying. In the sense, consider that this is the new version of application I'm just giving you here. All right. So here I'm going to add this. Okay. So what we did is the return type of the the path is now modified. We're going to realize when I run this code after this code walkthrough, we should see this is the extra point. Okay. If I go to the output here, so currently it does not returns the fourth key. While since I added now, and after I deploying this one, we should be able to see. Yeah. And then we have a response. Yeah. All right. So here, this is how your source code, consider that this is your Python Flask application code, right? So here in this case it's only one file, but in your business case it could be like a huge multiple folders, nested folders. Then we have a Dockerfile. So this Dockerfile is nothing but what it's doing is it is making your application as a Dockerized. In the sense, it's building an image. In that image, it is incorporating your application and making that as a container image. So the definition of the Dockerfile is very simple. It actually uses a base image, that is an image which is containing Python, and the name of the image is Python 3.10 alpine.3.18. Yeah. And in that one, you can also add the working directory app if there is a directory. In my case, there is no app, application directory, but if you have application directory, you can do this. Yeah. Then we have a copy. In the sense, this is the command which actually copies this source code, that is app, into the image and tries to do the next job. That is, once it copies all the source code here, in the sense when it does copy ... in the sense it copies all the so basically all the paths. In the sense, all these source code, all these paths will be, whatever the files and folders present underneath this existing working directory will be copied. And then we are actually installing the requirement.txt file. So as I said, this is a Python application. We should have a Flask installed in our system. So the Flask is been installed here by in the definitions. We are exposing the application over port number 500. So let me change it. So for just to make you that the application works, let's expose it on port 600 this time. Then we have an environment number. Then we have the command. In the sense, the last the part of the the Dockerfile tells that hey, what you need to do once the you have ran the so you have an image, you incorporated my application in that image. Now what the commands you need to run? So this is the Python API. The app.py file has to be run. This is the command it has to run when somebody runs my somebody runs my pod, or somebody runs my this image based the machines or image based basically pods. Yeah, like that. So this is all about dealing with your application converting into a source code, right? Now this is one part. Now let's go to the another part, that is, so basically so right now we were talking about this Docker and Flask, but now we have another thing, that is how I am managing the ECS configuration which actually host my application, that is which actually hosts this Flask application here. So let's see that. So I have written that infrastructure into a Terraform. So if I go to the my app.terraform.io, actually I am keeping my workspace in Terraform Cloud, which is a remote basically. So this is my app.terraform.io, which is nothing but subscription of Terraform Cloud. In that one, I have a Cloud Quick Labs app, org. In that one, we have basically we have the AWS ECS workspace. So in this workspace, I'm actually keeping the basically I'm keeping the the state of the ECS service. All right. So now let me walk you through that. How did I do that basically? Yeah. So here underneath the root of this repository, I have a file called main.tf file. So in that main.tf file, basically I have a module called module is equal to ECS. In this module, so basically this is a Terraform module. So when you say Terraform module, we do have a source. In the sense, we need to mention the source here. The source is nothing but it is pointing to a local folder structure. In the sense, this is a Terraform module of local path. Yeah. So here when you say source, in the sense, it will reference the files, Terraform file present underneath this subfolder, that is ECS folder. I'm going to walk you through those files as well right now. So right now, let's see what I have defined further. This is the VPC ID, nothing but the VPC which I have showed you just a while ago. This is the VPC. So here I'm not managing this VPC as infrastructure as a code, but you can manage it from your side as well. There is no problem in it. Yeah. And then I have a cluster name. So in my case, we are creating the demo cluster. So let me, so basically the cluster name I have given here is demo API cluster. Similarly, within the cluster, we're going to have a service called cluster service name, and the name of the cluster service is like this. And within the cluster service, we will have a task, and the task cluster name is this one. And to this EKS, to this ECS cluster, we need 4 subnets. So that's the reason I have added the subnet IDs here dynamically. In the sense, just a hard coding. But as I said, you can create it as infrastructure as a code. And then we have an execution role, that is this is the IAM role that you need to create with a trust, with a role trusted to a ECS-task amazon.aws.com. So I'm just going to show you that how does this role is all about. So if you go to the IAM service, this is my AWS account, and I'm currently in IAM service. In this one, I go to the IAM role, and here let me search that role. This is the ETL Lambda access role. That is the role I am using it in this case. Here in the trust configuration, you need to have so this service should have yeah, sorry, looks like I have pointed to this one. So this is the service. If I go to the roles, let's click on this role, and that role should have a trust relationship to the ECS. You see, this role has to have a trust to AWS principal, that is service principal, that is ECS-tasks dot amazon.aws.com. So that is the mandatory trust has to, or else your ECS service will not work. And underneath the permissions, I have given admin permissions, but in your case, you can give ECS permissions, ECR permissions, plus IAM permissions, plus other. Basically, you can keep it as a least privilege mechanism. Yeah. All right. So that is what this role ARN is been copied from here, and it is kept it hard coded here. But if you want to manage this role as an infrastructure as a code, you can do the same as well. Then we have an image ID. As I said here in the diagram, this ECS service is referencing this AWS ECR service by referencing its image ID. So if you go to Elastic Cluster, this is the URL, right? So that is what I mean. I have hard coded here. That is your private repository image URI. All right. And that is something you can get it from here as well. So once that is done, this is all about my module.tf file. So I'm going to save the changes which I made while I was explaining. We're going to run this code, and we're going to see the changes as well. So in the provider, I have a providers like this. I'm going to show it. So here I have a Terraform provider, which defines certain required provider. Since I'm deploying the infrastructure as a code for AWS services, so I have required providers for AWS. These are all the versions. I have a random provider as well. I have a Kubernetes provider as well. I'm not using Kubernetes provider here, and this is just a demo of how to host and service in the in the AWS ECS service. Then we have a backend here. that is the Terraform backend is been defined here. So our backend is remote, which is nothing but remote state file, and the host name is app.terraform.io, which is actually URL of the Terraform cloud. And this is my organization which I showed you, and this is the workspace which we created for this demo. Then we have a provider called, so that is for region, that is US West 1, because my all the services are sitting in US West 2. So that's all about the this one main.tf file plus provider.tf file. Now from this module, the invocation goes directly to the ECS folder. This is the ECS folder. Underneath that we have main.tf file. So this is main.tf file is the heart of the infrastructure as a code. In the sense, this file contains all the resources that is needed for this infrastructure as a code. So here, let me walk you through this file from top to bottom. Here what we are doing is we are actually reading the VPC by using a data type, and then this is the AWS VPC, existing VPC, and the variable dot ID, right? As I said earlier, so in the module we are passing these parameters, right? So these parameters are declared as a variable here. If you see VPC ID, cluster name, service name, image ID, subnet ID, everything is been defined here, whatever I selected here, right? So those variables will be referenced as variable dot. So that's the reason when I am seeing the data AWS VPC, it is referenced as var.vpc ID. So then we are creating the security group because we need a security group to control the inbound and outbound of the ECS service. That's the reason here we are creating the AWS security group. In the security group, this is pointed to the VPC which is being referenced from above. So this is VPC you see, and this is existing, and we are getting the VPC ID. And the name of the security group which I am creating is ECS security group. In that one, we are actually ready-made configuring the inbound rule, where from port is 5000. So let me make it as a 6000 because I modified as a 6000, right? So we need to change now 6000. All right. So that is from port 6000 to port 6000. This is protocol equal to TCP. CIDR block is nothing but source block. So the source block here is internet. Similarly, we have one egress role, that is everything is allowed. Yeah. All right. Then let's go to the next one, that is ECS task definitions. Let me explain you. That is AWS ECS cluster is a big container. In that one, we have a sub container called service. In that service, we will have a smaller thing called task, and that task definition has to be defined in an infrastructure as a code. So let's make it as a AWS ECS task definitions. So this will create a task definition. In the sense, basically it will define how your pod should be running, yeah, in layman term. So here what we are doing is, what is the name of your task definition, right? That is being referenced from the variables. Then we are giving the network mode equal to AWS VPC, memory equal to 512. The required compatibility is Fargate because I'm using Fargate service. Then the execution role, which I explained you just now, this role, right? This is ETL lambda role, which I showed you here as well. So that lambda role is also used referenced in a task. So this role will be consumed in ECS task or in the pod basically, yeah. And then we have a container definition. So this is the heart of the basically the task. So your basically the pod name will be, or in general container name will be Flask API container, the variable.image ID. So our container here, what we are defining here, will be created out of the image stored in a ECR, and that ECR, how it is been referenced by using the image URI ID. So the image URI ID is the reference here, like that, yeah. Then we have we are defining the size of the pod, that is within a container we will have a pod, yeah. That's the reason I'm saying a pod. So pod definitions we are like a CPU, memory. Port mapping is nothing but I need to again change it to the 6000 because I'm modifying it to 6000, yeah. So this is 6000 and protocol equal to TCP. CPU again we are defining equal to 256, yeah, 256 cycles. Then we are actually creating a cluster, yeah. So because creating cluster is a mandatory to to create a ECS service basically, yeah. So we are creating a cluster, and the cluster name is being referenced from the variables, yeah. And then comes the core part of this, the infrastructure as a code, that is AWS ECS service. So in that one, we have to give the name of the service that is being referenced again dynamically, because if I go back to the main, so we are providing the service name equal to Quick Labs API service. So that is what it is referenced here, and it is also referenced to the cluster which we created above. Then the task definition, it does reference to the task which we have created here. That is nothing but container basically, and this task definition, the ARN will be here. Yeah, so basically if you know the Kubernetes concept, that is multiple parts will be grouped together and that will be called as a service, and that is the service we are actually doing. So while you are doing it here, we are actually tagging a definition, that is task definition. Then we have a desired count equal to 1, in the sense how many parts do you want in the service, that is one part, and the launch type equal to forget. Yeah, forget. And then we have network configuration, that is subnet, security group, and we are actually having a public assign IP address, right? So everything is been configured here. So likewise, this is part, so basically this is the second part which I am explained you, that is how to define the ECS service configuration as infrastructure as a code with using Terraform, where the state of the Terraform is stored in a Terraform cloud. All right. Now, what I do is I'm going to walk you through the workflow, which is very, very important part of the demo as well. So here, let me tell you, this is the GitHub Actions, right? And that GitHub action definition is defined as a YAML file, and this will be placed under .github./work and /workflows. Underneath that, we create a file with the extension .yaml, and that will become as a workflow definition. If I go to the here, so that is where the workflow definition is all about. So this workflow is doing two jobs here. One, it is creating an image out of the the Dockerfile. The Dockerfile is nothing but it is pointing to an application which is hosted on this GitHub only, right? So basically what it's doing, it is cooking a Docker Hub image or building a Docker Hub image and pushing that Docker Hub image into AWS ECR. This is the one job. So how does it authenticating the ECR authentication? That is with using access key ID and secret. Yeah, this is the first task. Then the second task, main important task, is to create the Amazon ECS, which is basically it explicitly creating the Amazon ECS. That is, it's creating a cluster, it is creating a service, it is creating a task definitions. In the task definitions, we are actually implicitly referencing the AWS ECR, which is always to the latest image. All right. So that is how the dots are being connected here. Now let's quickly walk you through this the workflow file. The name of the workflow file is ECR ECS, which I just know basically ran in the starting of the video. Then it actually, this workflow gets invoked by workflow dispatch mechanism only. Then we have a job, and this is a single job containing multiple tasks, right? So in this one, the job name is so basically ECR ECS deployment. Why did I say ECR? Because we are creating our image into ECR, we are using that image and deploying the ECS, that is Elastic Container Service, right? Then the name of my this is my name of the job. It runs on the GitHub Actions or GitHub runners run on Ubuntu latest. Then we have a steps now, so I'm going to walk you through the steps. That is, first step is check out the source code. Then we are actually logging into my AWS account. That is, set up AWS ECR detail. In the sense, to connect to the AWS ECR, I need to have AWS account context. So the AWS account context are being set with using the IAM user ID and password, or IAM user access key ID and secret, right? With using AWS given GitHub action endpoint, that is the GitHub action endpoint for AWS, that is AWS-actions configure AWS credentials at the right version 1. Yeah, this is the GitHub endpoints which we need to use to set the context of AWS account, right? So here we are using the access key and secret of my IAM user, and that IAM user has a that IAM user has a full permissions on my AWS account, right? And I'm keeping these keys and secrets and the regions, everything on the my GitHub settings. If I go to the GitHub settings, so if I go to the GitHub settings, go to the secrets and variables actions, and here I have set those secrets, that is AWS access key ID, ECR repository name. This is the repository name. If you go to this one, this name, I'm just keeping it very secret, and this is super secret. All right. So then we have a AWS region, then we have a AWS secret, and TFC API token. So the TFC API token is nothing but the token of your user authentication. So if you go to the user settings and then go to the tokens, right? So here we will have a token, that is, this is the token which I created here. If you don't have, you can create it from here, and that is also been configured as a TFC API token. Remember, that is a secret. Yes, we need to configure it as a secret. Now that is where the settings is here. So here in this step, all those secrets are being referenced from the settings secret configurations, and then it does sets the context of the AWS account. Then it starts the next job. The next job is logging into the AWS account is not enough. You need to log into the AWS ECR as well. And that would be done by referencing the another GitHub action endpoint, that is AWS Actions Amazon ECR login version 1. Right? So you see AWS Actions in the sense that is GitHub Actions pertaining to AWS. And in that one, it is actually hitting the endpoint that is configure AWS credential, Amazon ECR login. Yeah. And to this step, I have purposefully given an ID because I want to check, I want to reference this, yeah, in the down the line. That's the reason. If you go to this one, this is the next step, that is build and push the tagged Docker image to Amazon ECR. And that is what it happens. I also given the ID to this task. This task has 3 environmental variables, that is ECR registry. The ECR registry has the value referenced from the step number above. And if you see here, that is what I said. Log in PF AWS ECR, in that one, get the outputs, get the registry. And then it also needs a ECR repository. The ECR repository is being referenced from the secret values. Then we have an image tag that is always latest. And after that, we are running the shell command, that is docker build and docker push. In the docker build, build basically it is actually running the docker build in the local working directory context. That's the reason we have a dot operator here. And then we are using -t command and passing this image, this ECR registry repository, and then tag. Yeah. So all these environmental variable are being used in this docker build command. Then we have a docker push, which actually pushes the image to the repository. All right. And then we are actually checking the status of the above stack, in the sense I want to make sure that image is always pushed first, and that's the status of the task always has to be successful, not a failure. So that is being checked here by referencing the ID of that particular task and the value of the outcome. If it is failure, then we are exiting it, or else it will continue to the next one. Right. So till now, what we have saw this particular stage, that is actually building the image and pushing into ECR. Now we need to do one more thing, that is create a Amazon ECS with the required configurations, eventually hosting the our Flask application on the Amazon ECS. How did we do it in the GitHub workflow? So this is how I did it. So first one, we are actually doing a Terraform setup. Here we are using the HashiCorp GitHub action endpoints. That's the reason we have a HashiCorp. Set up the Terraform, and the Terraform version is latest. Here we are using the CLI config credentials, in the sense I'm using the TFC API token, which I showed you. How did I set it on the GitHub action secrets. Then we have a Terraform init, which actually does the Terraform init. Then we have the Terraform validation task. Then we have the Terraform plan. So here we are actually running the Terraform plan, but captured in the ID, so that we just check the status of the plan. So what does this mean? In the sense, if the plan goes green, then only I need to go and apply, and that is what the check has been set there. Then we are actually running the Terraform apply. So that's all about the GitHub action workflow definition. Piece by piece I have explained to you. Now let's go and deploy this change. In the sense, let's go and deploy this version and realize whether are we managing the version control in a very basically very very basically step by step model, very controlled manner, and also it is been version control, right? So version control is the best method that you can manage the your basically your application. So let me say demo final. Yeah. So I'm just going to commit this. So I'm going to sync the changes. So what we are doing is we have modified something, right? So we have modified the port on which the application can be accessible. Earlier it was 5,000, now it is 6,000. Let's see whether the application becomes accessible in which path. Okay, so if I go to the source code again, just now there was a commit happened, and if you go to the ECS and go to the main Terraform file, currently now it is been exposed over the 6,000, right? All right, so now what I do is I'm going to rerun the so I'm going to rerun this action. So right now, if I show you the application, currently it is accessible on the port number 500, right? So it is returning only 3 key pair values. Now when I deploy the new version, it should return 4 key pair values, and it should not be accessible on 5,000 ports, but should be accessible on the 6,000. That is the change I am expecting. So I will just run it again, and let's go to the workflow now. So as I showed you, both the endpoints or both the API paths are working. Now let's deploy the latest version, that is let's consider it a version 2. So let me run it on the main branch again. So I'm going to run it. So what does this happens is basically it will try to create a new image and deploy that new image into the ECR, and then eventually update the ECS service, which will which will become exposed over 6,000 port. Yeah, that is what the expectation is. Here you go. It is very quick. It has logged in. Now it is pushing the image to the ECR. Looks like it's very fast. It is doing. So basically pushed, so as you see here, it is pushed. Now it is going to the Terraform stage. It is deploying now. And if you see, it is currently initting, it's validating. Validation is complete. Terraform plan is in progress. Currently, it is evaluating the Terraform plan, and since it is identifying the changes here. So currently, it is doing the initializing the plugins and the modules, right? So once this has been done, then it will go for the Terraform apply. Then we're going to realize the changes. Okay, so if you saw here, there are changes here, right? So it has identified that there is a service going to change it here. There's a changes in the service. So that's the reason the summary says that it's going to add the 2 changes, 0 to destroy. All right. So let's wait for 2 more minutes so that it completes the Terraform apply, and then we see that now application becomes accessible over port number 6,000. What does this mean? In the sense, this is previous version was accessible on the 5,000 port. Now the port is changed to 6,000, which means that version 1 to version 1.1. Yeah. So everything is managed here as a code, infrastructure as a code, right? That is actually basically the standard of managing the infrastructure. Managing the infrastructure of enterprise, enterprise or enterprise grade business applications. So currently it is doing the app, the apply. It is running the apply. So here you go. So once it goes green, we can go ahead. So here, if I go to the repository, that is ECS demo. If you go ahead and click on this one, this is the latest image which just now got pushed. That is at the 17, at the 15.11. Yeah. And here you go. The deployment got complete very fastly, and the required changes are applied. If you see here, it has added 2 changes. All right. Now our image is up and running fine. Let's go to our service, that is cluster first. So cluster is up and running fine. There is no pending, 0 running, in the sense one service is running, one task is running. We have a service, we have the task, we have the infrastructure, we have the metrics. So everything could be explored from your side. Now let me directly jump to the task because everything is explained earlier. Now let's go ahead and open this. Yeah. All right. So while it is running, it is actually, so this time the IP address is ending with 181.129. So if you go to this one, 189.121. So looks to be 181.129, 181.129. Okay. All right. So now if I refresh it, it should not, basically it should not listen to it. Yeah. Here you go. It is now delaying. Yeah. All right. So it says site cannot be reached. Now what I do is I'm going to switch to the 6,000. So currently we are hitting the path time. Yeah. If I hit this one, so currently it is accessible over the the 600. So let me again open it again basically. So let me open this. So what did we do is we actually expose the service over over port number 600. Okay. So if I go ahead, so we have allowed port number 6,000, and the container is also open on port 6,000. Right. So basically why it is taking a delay, because remember here the service is just now deployed. It's gonna take some time. All right. So now what I do is I'm gonna put a colon, and instead of 5,000, let's say 6,000, and try hit and basically time or random. Let me say random as well. So random. Yeah. So basically looks like service is still up and running fine. So let me look into the basically let me look into the changes that has happened here, right? So just a second. So let me look into this. Okay, I just realized that so if I hit this again, site is not reachable, even though the configuration is fine, but site is not reachable. Why? Because we have missed some configuration here. As you see in this application, so everything is fine. We have modified, but if you try to go ahead and search with the 5,000, right? So we have some configuration missing here. So in the sense, the port, in the sense, the application is not listening on the port number 6,000. Okay, that is a missing piece. What I do is I'm going to modify that change and make the commit again, and we need to run the next version, right? So this is how the basically we manage the Flask application with using infrastructure as a code. So I will say updated, yeah. So we're going to make this change, synced again, and we have to release the, basically we have to release it again. Once the release is completed, we should be able to see that, application is listening on port number 600. Currently, it is not listening on port 6000, sorry. So it is port number 6000, not 600. So what I do is, I just made the further required changes and upstream, synchronized. Let's run it again so that, it modifies the application as well. So let me run it. So what happened is, in our application, in our app.py, we were missing this configuration. That is, so whenever application runs, it has to listen on port number 6000. Earlier it was 5000, but we modified to 6000, but we missed this configuration that is here. And that is the reason, our application was, our application was not reaching. Once this deployment goes green, we should be expecting that, the application is up and running fine. So basically, this is also a troubleshooting session that, I'm going to show you here as well. So currently it is going very fast. If you see here, yeah, so it should be working as expected now. All right, so currently it is doing a Terraform plan. Once the Terraform apply goes up, once the Terraform apply goes green, we should be seeing that application working as expected. All right, so currently it is running the Terraform apply, Terraform plan and Terraform apply. So meantime, let me refresh the, so let me refresh this site. So it will become automatically responding once the deployment goes green. So if you see here, there is a slight change here. So it says that service going to change it now. Why? Because, so the ID is also getting changed. All right. Okay. So once this is plan is done, now it is running the apply. Once the apply goes green, we should be able to see this application responding as expected. Okay. So while it is running parallelly, remember that, parallelly, let me take it here so that, this is like a real-time demo for you. So currently the the Terraform apply is running fine. What is this doing under the hood? If you understand in a real time, right? So basically it will create a new version of the image, which actually has a right configuration. So if you refresh it here, we should have the latest version. The latest version is pushed just now. If you see here, it is just now pushed. Yeah. All right. So now the apply looks to be goes green, in the sense it went green. If I refresh it here, the Terraform apply got clean. If you see here, so currently it is finishing or wrapping up the Terraform apply. And that's all. So basically, if we refresh it here again, all right, so the Terraform apply got updated. Now let's go ahead and hit this time. We should be able to respond, we should be able to respond it basically. So since this is just now deployed, if I go to the ECS, and let's see, what is the mistake that it is happening basically. Yeah. So if I go ahead and see the task, yeah. So if you go to the task, yeah, so it is currently it is in running stage, and this is the IP address. This is the IP address. If I open it again, so let's open it from there. Okay, so let's see if it works. All right, but basically, what is the theme here which I wanted to convince you here is, it works in the sense it actually manages your image versioning control as well, and parallelly your cluster application is also getting pointing to the latest version as well. So right now it will not work on this one. So let's, as you see, the site is not reachable. Let's make it to here on port number 6000, and let's see if this responds. Yeah, time, or let me say random. So it looks like, so this will take some time eventually, as I showed you earlier. So basically, we're gonna have this. If we refresh it after some time, basically yes, it should be working, because it's gonna take time. As you know that, the once the pod is been deployed, it's gonna take some time to get listen. So by that time, you should be able to see the the application listening on port number 6000, which is a version 2 of that one. Yeah. All right. So with that note, I have successfully shown the things not to be shown in this video. Finally, I can request, please do subscribe my channel. That would really encourage me a lot. With that note, thank you. Thanks a lot, and see you in the next video.